Thanks, Ryan. And thanks everybody for joining. Today we're going to talk about creating SQL queries using data interchange, and we're also going to talk about using database export. And the presentation and then what you signed up for was data interchange export. But I'm going to use database export as kind of a precursor tool, and then migrate the queries from the database export into data interchange export. And we'll kind of cover the pros and cons of using both tools. They both allow you to do the same things, but there's some advantages of database export over data interchange export as you're building these things out. And so for the purpose of working today, I've made those two modules my favorites, so I can go back and forth between them. You can search for them off of your menu. Database export is found under the System Utilities menu, and data interchange export is found under the data interchange module. So I'm going to just quickly kind of do a quick overview of the two functions. Database export provides you access to all of the tables and views in your Counterpoint database, including any custom tables or views you have added. It allows you to declare what the file name for the export is and where you want to place that file, and allows you to kind of pick and choose what columns you want from those tables and views. Database or data interchange export also allows you, and this is really what we're going to focus on today, to write your own SQL queries, which is kind of a daunting task at first, and that's kind of why I wanted to cover this material, because as you start getting into it, you realize it's not as scary as it looks. I think of, like, someone who's writing or composing, the worst thing is the blank page. And that's really what you start with a SQL query when you're doing it from within Counterpoint. But once you get started, you'll find that most of the tables you're going to use are the same tables over and over again. And most of the columns within those tables are also the same columns over and over again. So while there are hundreds of tables and thousands of columns in those tables, you're really only using a very, very small percentage. And writing these queries really becomes very quick and easy. And I'll show you some shortcuts at the tail end if we have some time to actually use Counterpoint to build them for you. The advantage of data interchange export is that once you've built the query, you can save the query parameters the same way you save report parameters. So once you've built something, you can save it inside of Counterpoint and run that again tomorrow, next week, next month, next year, the same way as you ran it last time. So it provides the consistency, saves your formatting, everything that you've done under a saved parameter. Database export is a little more interactive. I still have access to all of the same tables and views, including the customs that I have in data interchange. I can still decide what I want to name the file and where I want to put it. I can still create my own custom SQL queries and build them from scratch. But the advantage of, find a table with some data in here, customer table. The advantage of database export is as you're working, you can get a preview of what you're building. So you can see that it meets your expectations. So if you're using data interchange, you would have to build it, export it to a CSV file, open that in Excel or in Notepad or in something else, and make sure it works right. Whereas here, you can do that in real time. Every time you make a change, it just instantly refreshes. So those are really the two big differences between database export and data interchange export. And so I usually start things out over here, and then once I've built what I've wanted, I just copy the query and paste it into data interchange export. So I'm going to start with a simple query, and assuming that there are people on this call who have never written a SQL query in their life. So while that may be boring for some of you who have written very extensive SQL queries, I want to make sure everybody can understand the basic building blocks of this. So when I'm working in either module, I'm going to say that I'm going to use a SQL query, which means it's a custom query that I'm going to write myself. And every time I do that, I have to click on the custom SQL button to open up that little window so I can actually start building my query. And so the SQL statements we can create inside of Counterpoint are really only select statements. We can't create views, we can't create stored procedures, we can't delete records from tables, we can't modify tables. This is a very benign, security-friendly access to the database. And that's another reason we wanted to cover this today, is that this is a great way to work with your data, look at your data, see your data, but you really can't mess anything up. You can't modify any of your data, you can't modify your database, you can't corrupt the database, you can't really do anything to the database that would cause any harm. And so all of our queries are going to begin with a select statement. And the select statement is, here's what I want to see. Just think of it that way. And then once we build our select statement, and I'm going to copy and paste in things from the worksheet that Ryan sent out to everybody. And so you'll be able to duplicate all of these queries by copying and pasting them into your data interchange or database export the same way I'm doing it. And I'm going to copy and paste them just so you don't have to watch my horrible typing. But so as I'm building my query, I've got my select statement saying, here's what I want to see. And then I've got a list. Picture this is the grocery list. Here are the things that I want. I want milk, bread, eggs, lettuce, tomatoes, and a frozen pizza. In this particular case, I'm asking for the item number, the description, category, subcategory, the vendor number, selling price, and my last cost. So as I build my select statement, I've got the word select, I've got my grocery list, and the next thing I need is, where am I getting this from? Am I getting this from the supermarket? Am I getting this from the convenience store down the street? Am I going to the hardware store and trying to find, bread and milk? And so in this instance, I'm grabbing this data from the item table. So I've got my select, I've got my grocery list, and I have my table name. So if I click OK now, notice database export automatically updated, and I'm looking at the columns that I've requested. So that's kind of the minimum of a SQL statement. Select, which is show me, columns to show me, and from what table. And we're just going to kind of build up from there. So the next thing we would probably want to include is a filter. And we're all kind of used to using filters in Counterpoint because every time we run a report, we filter based on a date range or a price or a category or a subcategory or a vendor. And we're going to do the same thing here in SQL. And so I'm pasting it, but you could type it out. And when we build the filter is built on the word where a condition exists. So the condition I'm using here for starters is where the price is less than $5. If you kind of read that, where price one less than 5, kind of reads like English. This is not a really tricky programming language for simple SQL queries. And if I click OK, it drops the list, and now everything in my price one column is under $5. Next thing I'm going to add to that is a sorting order. See, as soon as I start typing, I make typos. I have to go back to copy and paste. So my order by statement is just saying order by price one. And when I order by price one, I have the option of ordering it in a descending format or an ascending format. And ASC or DESC for ascending or descending are the abbreviations we use. And now if I click, now the highest priced item is $4.99, and it'll go down to 0 or whatever my cheapest product is. If I change descending to ascending, 0 is my cheapest priced item. So building a basic SQL query doesn't take a whole lot of effort. There's not a whole lot of paragraphs of weird programming language. It's a very English-oriented programming language. So the next thing I want to talk about are the filters, this where condition. So I'm starting off with a very simple condition of where price one is less than $5. So I'm going to add another option here. So now I'm looking for things that are less than $5 or over $100. And again, this would be the exact same thing you would do in Counterpoint if you were building your filter on, with price one is less than $5. And then you would change the joiner of and or to or and add another condition for price one is greater than $100. And let's sort that descending just to get those $100 items up on top. And so these are the most expensive products I have that are over $100. And if I go to the bottom of the list, I'm going to find things that are potentially under $5. And there they are. So we can build complicated filter statements in our query. So the next thing I'm going to do is kind of combine my pricing filter with a category filter. If I'm typing this in from a syntax standpoint, should go back and kind of cover this a little bit. I can't say category, I have to use the actual column name, but if I'm looking for things in my golf category, notice I'm putting apostrophes before and after golf. And you'll also notice when I did my grocery list up here, I separated each column with a comma. If I don't separate them with commas, I'm going to get an error. I do not put a comma after the last column in my grocery list. There's no comma after last cost. So now I've built my condition of price one is less than 5 or over 100, and everything is in category golf. And all of my expensive items are probably in my golf category. But you'll notice that my cheap items are not necessarily in my golf category. I've got service, HH, whatever that is. And so when I'm building my filter on my query, I want to use parentheses to kind of separate things out. So it's really important that I think out what I'm looking for, which rows I want returned by this query. So if I'm looking for things that are less than 5 or over 100, and all of those are in the golf category, I'm going to put parentheses before and after the price one components of the filter. Separate that out so it's a little bit easier to see. So now I'm only looking at golf items, and anything that's between $5 and $100 is not in the list anymore. So parentheses make a huge difference in how this is read. Just for laughs, if I change this to price is less than $5 or it's over $100 and it's in the golf category, I'm going to get those non-golf items back in that list. So how you use the parentheses makes a huge difference in how it interprets that statement. So the next thing I want to do here is I want to incorporate data from another location. So my item table is kind of very simple: items, descriptions, categories, prices. But I might also want inventory information that shows me how much I have on hand and what the specific average cost is at my various locations. So when I do this, I want to incorporate my inventory table, which is the IM/INV table. And so I want to link my inventory table to my item table. And the way we do that is with a join. Start out simple with an inner join, and we'll explain it what an inner join is in a second. And so I've got my inventory table joined to my item table, and now I'm able to start incorporating things from the inventory table as well as my item table. And so I'm going to start adding things like average cost. And quantity on hand. And it might look better if I put the location ID in front of the cost and quantity on hand. And so at this point, I'm going to get an error message that I want to explain here. So I've got 3 new columns added to my query for my inventory location, quantity on hand, and cost. I've added the join of the inventory table, but I have to tell the system how I want to join the item table and the inventory table together, how I'm combining those. And I'm linking these based on a common element between the 2 tables. So in this particular instance, both the item table and the inventory table have the item number. So that's how I'm going to link one table to the other table to find the corresponding record. And so I'm linking table 1 to table 2 based on the item number equals the item number. And notice I had to type out IM item number equals IM inventory item number. And so when I run this, I am going to get a little bit of an error up here on this first item number. And what this is telling me is it doesn't know which table to pull the item number from or the last cost from. So I'm going to have to go back to my query, and when I ask for the item number, I have to tell it which table I'm asking for that from. So just like when I link the 2 tables together, I had to say the IM item table's item number. I'm doing the same thing here. So I use the table name and a period as a prefix in front of the column. And I'm going to do the same thing here next to last cost. That error goes away. And now I've got the columns I had originally plus the last cost, or plus the average cost, quantity on hand at each location. This is not in the handout, but we'll just add it real quick. We've been playing with this order by price ascending. We might also want to order this by location. So I might request this to sort by location, and then within the location, sort by price. Keep our location data together. I might not, sort up to you how you want to do that, but you can sort by multiple columns is what I'm getting at. So when we link this data, we used an inner join. I said I would explain that in a minute. And so if I use an inner join, the inner join can actually act like an additional filter like I'm filtering based on price and category. And the way that works is when I join the two tables together, it's looking for records that are in the item table that have a corresponding record in the inventory table. So if we've created new items, but we haven't created inventory records for them, for example, using an inner join would keep them off of my output of this query. So if I want things that are in my primary table, which is in this case my item table, and I want the inventory records where they exist, I would change this from an inner join to a left outer join. And that's going to give me all of my items. And if those items have inventory records, it's going to give me those as well. And that changes the output list. I'm going to change that a little bit as well. Going to add another condition here. Or quantity on hand not equal to 0. And notice now, just judging by the size of this toolbar, it eliminated a lot of inventory records and cut down the list of items that are displayed. If I change that left outer join to an inner join, anything with no inventory records at any location, because I filtered it based on the quantity on hand, will disappear from this list. About the same. We'll do a few more examples of that inner join versus the outer join. We'll get over to sales history where it becomes a lot more critical or a lot more obvious. So the next thing I want to talk about is doing a little bit of math, because everybody likes math, right? So I've got a quantity on hand, and I've got a price one value, and I've got an average cost. Maybe I want to know what's the retail value and the cost value of my inventory. We can do multiplication, we can do division, we can calculate other things here. So if I want to take my price one and multiply it by my quantity on hand, just simple math, simple multiplication. When I'm doing that, I probably want to give it a column name. And I can do the same thing with my cost. So I've added two new columns for a retail value and a cost value. So we can do simple multiplication, addition, division. You can do much more complicated formulas as well. The next thing I want to do here is I want to take my data. I'm going to get rid of this quantity on hand thing, so I got more data to play with. So I might not want to see all of my item data, and I might not really want to see all of my item data at all of my locations. What I might want to see is my items with how many I have across all of my locations. So I want to see a retail value and a cost value for the entire company rather than location-specific detail. So when I customize my SQL query, I am able to group my data. So I'm going to kind of get rid of this order by, because we're not going to need that anymore. And so when I look at these list of columns in my grocery list, I'm going to either make every single one of them a group by element, or an aggregate value. Aggregate value sounds like a real technical term. It just means it's some kind of evaluation, some kind of mathematical formula. So, example, it could be a sum, total of the column. It could be the maximum value of the column, or the minimum value of the column, or the average of the column, or the count of the column. We'll do a couple of examples of those. But things like item numbers and descriptions, those are going to be my group by values. So I'm going to take this and I'm going to group this by first couple of columns there, the item numbers, the descriptions, kind of the boilerplate that extends across all of the multiple records. And I'm going to group my data by those. And notice I'm stripping off that last comma in the group by. And then I'm going to eliminate the location ID because I'm going to kind of compress the locations into a single row. And I'm also going to remove the average cost and quantity on hand. And so now I'm going to take these two formulas that we just built and I'm going to total them. So I'm going to have a total retail value and a total cost value per item, and we're going to eliminate the location specific detail. So to total those or summarize those, if I just want to add up the column, the code word is sum. So I'm summing the price one times the quantity on hand. And notice I'm putting parentheses around that because I want to do the multiplication, and then I want to sum that column as my retail value. And I'm going to do the same thing for my cost value. So now I've eliminated my location detail. I don't see a location field there anymore, but my retail value is the total of this product across all of my locations, and the same thing for my cost value. I'm going to compress that down a little bit further and eliminate the item number and description, and we're just going to total this by category, subcategory combinations. So to do that, I'm eliminating the item number and description, and I'm also eliminating that from my group by statement. And now I'm going just to my category, subcategory, vendor combinations. Let's eliminate the vendor from that mix also. The other thing I have to eliminate there, because I chopped out the item number, I also want to chop out that price one. So now I have got my golf category, and the reason I only have the golf category is because that's part of my filter. Category equals golf. And I've got the various, oh, got less cost in there too. There we go. So there are my category, subcategory combinations and the cost and retail values of those products. So you can see very quickly with very little syntax, and this is, a couple sentences worth of typing, I've got an export of category, subcategory valuations. So let's move on to something a little bit more complicated. And well, before we do that, When I was linking tables, we were linking the item and inventory table. And then we had to, when we had them back in our select and our group by statements, we had to, in some cases, insert a prefix in front of like the item number column or the last cost column to tell it which table we wanted that data from. We can use aliases so you don't have to type so much stuff out. So if I want to call my item table, table I, and my inventory table, maybe table N, then when I'm mentioning things where I have to give it a prefix for the table name, I can use the alias. You don't have to do that. It does work. It's a little bit of a time saver. There are some cases when we get further along with the webinar where we're actually going to create some custom tables on the fly, and we do need to give it a table alias. So it's worth knowing how to do that. So let's kind of jump into that now. So far we've played with item tables and inventory tables. Let's talk about ticket history, which would be another thing that you're likely to start grabbing data from. I'm just going to kind of start over from scratch. And so I am going to grab a couple things here. So I'm going to select a couple columns. I'm going to select my item number, my description, category, subcategory, kind of the same stuff we had before. I'm going to grab the location. Yeah. The reason I'm breaking this up just so I can identify where things are coming from. So these first two lines in blue, these are all going to come from my item table. And then the next few lines are going to come from my inventory table, or my inventory table and my item table. So I've got quantity on hand and retail and cost values, just like we had in the previous export.
This is on page 7 for everyone following along on your worksheet.
And so I'm using my item table as table I. And now I want to link in my inventory table as table N, just like we did previously. And so I can test what I've got there. So I've got my items and inventories, kind of like we had before. And now I want to add in some sales history information. And so when I add sales history information, I don't want to link this query to my ticket history. Because if I do, it's really going to mess up the math I've done in here. And it's going to really mess up the number of rows I have output. So right now I've got maybe, I don't know, 50 to 100 rows of output data. But if I've sold these items hundreds of times, when I link my ticket history table to this query, it's going to link each item to every instance that item was sold. So if I've sold one item 100 times, I'm going to get 100 rows of output for that single item, which I want to avoid. So what I want to do here is I want to kind of create a little subquery. And I'm just going to copy and paste that in. And so my little subquery, and we can run this on our own. is going to look at what we sold. So I'm looking at my ticket history line table, and I'm summing up the quantity sold. I'm summing up the extended cost as a cost of goods sold, and I'm summing the extended price as my sales dollars. So I'm going to get my item number, my location, my sales dollars, my cost of goods sold, and how many I sold from the ticket history line table. And I've got a date filter in here already. And I usually like to filter based on line type. And I'm looking for sales and returns. And this is a kind of a best practices filter to use all the time whenever you're writing a query against sales history. And the reason I do this is because Counterpoint writes data to the ticket history line table that has not been sold. So if you're processing orders and you're partially delivering those orders, you may have U for unshipped lines. You might have A records for drop ship orders. There might be some other things in there that would impact what's being included in the output. And that could impact your sales dollars and give you some reconciliation issues. So I usually like to add that as just sort of a best practice filter. And so just like before, when we were grouping our output by category and subcategory, here I'm grouping my sales history by item and location. And so here's a little trick we can do in data interchange, a couple of tricks you can do. Just putting 2 hyphens here. What the hyphen does is it skips the line. It turns the line into a comment. So what I've just done is I've executed a little inner microquery for my sales history query. So now I'm looking at item numbers and the location, my sales dollars, my cost, and my quantity sold. I'm not looking at this portion of the query. I've just turned those lines into comment lines, so it's not interpreting it. And the reason I would do that is to test my little inner query. The other way you can do that is a slash and the asterisk, and an asterisk and a slash. So that basically says this is the beginning of the comment and this is the end of the comment. So don't do anything on those lines, just treat them as a comment and do everything after that. So that allowed me to test my sales history query, which is not all that different than the query we did on the inventory table, where we compressed all of the inventory records down to just a single record per item. Here we're compressing it down to a record of all the sales history per item at each location. And so this is actually kind of producing another table. So I've started with my item table, I've linked my inventory table, and I'm going to link those things together to my sales history table, which is a virtual table just sort of being created by the query. And so since I'm kind of treating this as a table, I'm going to give it a table name of S for sales. And just like I joined my inventory table with an on statement, I'm going to join my sales history the same way. So I've joined my item to the inventory, and then I'm also going to do an inner join, and then we're going to flip this in a minute. And now I'm not going to name a table. I'm using this as the table. And I come down below it. So I'm linking my item number from my item table to the item number in my sales history table. And I'm also going to link based on the inventory location ID. And that's going to be in my inventory table or table N. And I'm putting spaces in here just so you can read it a little bit easier. They're not necessary, but whatever makes it easier visually for you. So I'm linking by the location ID in the inventory table to the location ID in my sales history table. But notice it's not really the location ID, it's the stock location ID. So we're linking by common elements, but those common elements might not be named the same thing in different tables. So now I've got my items, descriptions, categories, subcategories, selling price, how many I have on hand, retail value, cost value of what's on hand. Notice I don't have my sales or my cost of goods sold yet. And the reason I don't have them is because I haven't asked for them. So I'm going to come up into my select list, my grocery list. I'm going to add a comma after the last line. And I'm putting that s.sales and s.cogs. I don't need the s dot. I only need them if that column exists in multiple places. Doesn't hurt to do it though. And now that I've asked for them, they should be out there on the right, and there they are. So with a little bit more than a paragraph of text, I've linked 3 different tables. I've summarized inventory valuations and summarized sales history at each of those locations. So at this point, if I really like that query, this is everything everybody wants. It's wonderful. I'm just going to copy that. And jump over to data interchange export. I'm going to use a SQL query, and I'm going to edit that SQL query, and I'm going to paste it in. Great if I could spell amazing. I'm going to always name this my amazing sales history query. Put the .csv on the end when you name the file. If you don't, it doesn't know what file type it is, and it won't automatically open in Excel, which is probably what you're going to open this with by default. So if you name it .csv, it'll have an Excel logo on it. And so now I'm going to save those parameters. And then I can export that. And if I drop into my documents folder, there's my amazing sales history query. Notice it's got the Excel symbol on it because I added the .csv. And it opens in Excel. And next month or next week when I want to run that again, I can just go back to data interchange and load those parameters. And there's my webinar for sales history. I load it. It remembers the query. It remembers the file location. If I need to change that date, I can edit the SQL query. And I have a date in here of January 1st, 2020. I could update that to 2023 and get a different output set. All right, so we've talked about items, inventory. I want to talk about inventory history. It's another kind of common source for pulling data from Counterpoint. So when we did, actually, before we jump over to that, let's do something else real quick over here. We were looking at sales history, which is really a copy of everything that's been sold throughout the system. A picture of a stack of all of the receipts out of the receipt printer for all of your sales transactions. If I change this inner join to a left outer join, it's going to start including a lot more rows in my output because it's going to give me everything from my item and inventory table. And if I've sold it, it's going to give me the sales information. Using an inner join, it only gave me things that I have sold. And so now when I look at sales and cost of goods, notice they're blank. Everything that's blank, I've never sold. So that inner join versus a left outer join is a lot more important when you start linking sales history. The other thing you might want to do here is if you're going to export this into Excel, having a blank value or a null value in these columns might make a bit of a problem if you start trying to add those columns up in Excel to get us total sales dollars and a total cost of goods. And so what I would probably recommend you do, I do this all the time, is we can convert null values into a 0. That's going to look a lot cleaner in Excel, and it will make your addition or your mathematical formulas a lot smoother if you're working them in something else. And so the way we do that is there's a statement called COALESCE. And what COALESCE does is it takes the first value that isn't blank or null. And so when I do a COALESCE statement, I use the word coalesce, and then I open it with a parentheses. And so what I'm looking at is the, oh, sorry, let's not do quantity on here. Let's do sales, cost of goods. So I'm looking for my sales, but if the sales is blank or empty, I want to output a 0. And then a close parenthesis. And because I've kind of built a formula around that, I will need to name the output column. I'll show you what happens if I don't. So if I coalesce my sales with 0, that means if sales is blank, give me 0. If sales is not blank, give me the sales. So now notice I've got zeros instead of nulls or blanks, but notice it calls it field. It doesn't call it sales anymore. So because I've kind of turned that into a formula, I need to name it as sales or whatever I want to call it. I can call it the same thing. There we go. So now they're called sales, cost of goods, and quantity sold, like they were before. And I've got zeros instead of blanks or nulls. So let's play with another query that looks at inventory history. And I'm definitely going to copy and paste this one in. And so what I'm looking at here, again, I'm using my item table and my inventory table. So I'm getting things like item number, description, and category, and price, quantity on hand. Same kind of stuff we had before. But now, notice I've got table H over here. And table H is going to give me a quantity sold and a sales dollars. But I'm also going to get receivings and the retail value of the receivings and the cost value of the receivings. And so what I'm using, kind of using the same strategy I used a minute ago with my sales history. I'm tying my item and inventory tables together, and then I'm linking that to another little temporary table called table H. And that table is the inventory history quantity view. The table name is VI, INV for inventory, VI is view, hist quantity. So the inventory hist quantity view ties together inventory adjustments, physical count transactions, quick assembly transactions, sales, receivings, returns to vendors. Everything you can do to change the quantity on hand of an item is tied together in this view. And so when it ties it together in the view, it takes tables that look very different. Sales history tables look very different than receiving history or RTV history or adjustment history or physical count history. But it makes the data look the same, kind of creates aggregate values of how many were sold, at what price, at what cost, at what location, what was the item number, what was the date, similar columns between all of these different historical transactions. And when it does that, it puts a little character on the beginning for the transaction type. So a transaction type of S is a sale, and a transaction type of C happens to be purchasing transactions or receiving transactions. And so C transactions actually include quick receivings, and returns to vendor. Sales transactions include sales and returns. I think I even put in a list. Yeah, I did. I believe I put a list of the transaction types in the Word document that Ryan sent along, or the common ones. You can separate receivings from quick receivings and RTVs if you want. There's, in addition to the type column, there's actually a full type column which distinguishes quick receivings from receivings and RTVs. The full type distinguishes sales from returns, a few other things that are distinguished. So I'm using my inventory history view, and I'm filtering that view by a date range. And just like we grouped our data before, I'm grouping it by item and location, same way I did it when I was playing with sales history a minute ago. But I'm adding in here, put some spaces around this, a case statement. And a case statement gets a little more complex. It's more of a programming trick. And a case statement is just asking if a condition exists. It says, if it's a sale, then we're going to grab the quantity. And if it's not a sale, I'm going to put a 0 in the column. And so it looks at each record and says, are you a sale? If yes, I want how many were sold. If not, I'm going to add a 0. And we'll do the same question with all of my. Is this a receiving type transaction? Yes or no? So it's looking at every record, and if it's a sale, we're going to grab the quantity sold, We're going to do the same thing for the selling price. We're going to do the same thing for the selling cost. And then if it wasn't a sale, it might have been a receiving. So if it was a receiving, grab the quantity of the transaction. Otherwise, we're going to grab 0. So when we build a case statement, this is kind of the basis of a case statement. We use the word case, and then we have some kind of a condition. And then if the condition is true, use the word then. If it's true, which column do we want? And if it isn't true, we probably want a 0. And then whenever we use a case statement, we have to end the case statement with the word end. So if I replace those, I can replace that with type equals S. Now that's starting to look like what I had up above. But because I'm grouping my data by item and location, I want to summarize that column. And then I want to give it a column name. And again, that's all in the handout. And so if I want to see what this is doing, again, I can comment out the top of the report. And the bottom of the report. So that sales history is giving me my item number and location, my sales at quantity, cost, and retail, and my receivings in quantity, cost, and retail. And I want to link that to my item number description and my quantity on hand at the east location and the main location and location 4. So if I take those comments off, now I've got my item, its description and category, and then at each location, how many I have on hand, how many I've sold, how many I've received, and notice I'm using a left join to join the history. And that's why I've got blank values for the quantity sold and sales. And if I want to order that by sales, descending, so I'll put my bestseller on top. Sorry, it's not S sales, it's H sales. And there's my bestseller on top. Got one more query I want to show you real quick. Very unrelated to items in inventory and sales, but it's something that a fair number of my customers use who pull data from Counterpoint for accounting purposes. And what I want to look at is distribution table. So this is the general ledger distribution activity that's created by sales and receivings and transfers and everything else. And so our distribution table contains are things like the event numbers and the dates and the general ledger amount. And it also contains the general ledger account number. And so if you've got profit centers as a segment of your account number, Counterpoint doesn't make it very easy to pull general ledger activity by profit center. So it's a really good example of a good custom query. And it also gives us a chance to play with left, right, and substring commands. And so I'm just going to copy and paste this in. And so we can do the same type commands in Excel. So these aren't really foreign or alien type commands, but the left command gives us the first 4 characters of the account number. So I'm saying left, the account number, comma 4 means the first left-hand 4 digits of the account number. So that's going to be my main account. And then again, I have another case statement here, and I'm using the substring. So if I use substring, I'm going to use a different chunk of the account number for an example here. If I substring my account number, I want to start that at position 2, and I want the next 3 characters. So that means I'm eliminating the first digit of my account number and grabbing the next 3. And I'm going to call that the middle of my account number. So my main account is the first 4 digits of the account number. The middle of the account number, I'm taking the next 3 digits. So I'm eliminating the first digit. I'm grabbing from digits 2 through 4. So 2090 becomes 090. So this is an example of using a substring command to kind of get at or parse up a column and grab specific digits from that account number. So I've got my main account based on the first 4 digits. And then if I had a profit center, it would probably be at position 6. So I might have a 4-digit account number, a hyphen, and then a 2-digit profit center. That's kind of my example here. So I'm grabbing from position 6, and I'm getting 2 characters. And I'm doing that in a case statement, just like we did in the last extract. So my case statement is saying, if position 7 and 8 are blank, then output is 0, 0, else output those positions. And I want to add up the general ledger activity, so I'm summing my distribution amount, and I'm going to group that by the profit center and main account number. So my group by is including, and notice I'm still using the left and the substring formulas in my group by statement. I can't say group it by the profit center. I have to actually group it by the formula. So now I've got my main account and my profit center, and the sum of the general ledger activity by those combinations. And if I had 4 different profit centers, I would have rows here for account 1005-01 and -02 and -03. And then I could order that by profit center or by account. I could filter it by profit center. It kind of gives me a lot of different parameters that I can play with. Felt a little rushed there at the end, but I got through pretty much everything in the worksheet. Are there any questions that anybody wants to go back to? I was expecting to have Ryan pepper in with some questions along the way, and I see there's a bunch of chats in there.
Yeah, there's some comments. Alex provided a good graphic for SQL joins that I'll share with you a little bit later. We do have a question from Wes. He says, when using item or inventory tables, does it matter if the items are gridded or not?
It does. If I go back to, I'll paste it in real quick, one of those earlier selections where it was just the item and inventory table. What I would get would be the sum of the color size combinations. So, for example, with this query, here I've got my item data and I've got a summary of the inventory table. The quantity on hand would be the quantity for all color size combinations. We would not output any color size specific information here. If you want to get into color size information, there is an inventory cell table that does that. And there we've got the item number, the location, all the colors, all the sizes kind of exploded out into a single record, and including the third grid dimension. And then the quantity on hand, mins and maxes for that color size combination. So if you want a single export of inventory on hand for non-gridded items and inventory on hand for the color size combinations of gridded items, what you can do, notice everything in this when I'm selecting from the inventory cell table is just for gridded items. So if I select, it's super quick, item no, comma, location ID, comma, so I've got my item, inventory, location, and then the dimensions and the quantity on hand. That's going to give me all my gridded items only. And then I also want putting 3 asterisks there, which kind of simulate what you're seeing in grid dimension 3, the asterisk. So I'm going to have an asterisk as color, an asterisk for size, and an asterisk for the third grid dimension. So what I'm asking for is the color size information I have for the gridded items, and then, so what's on hand for the gridded items, and then what's on hand for the non-gridded items. So I'm linking my item table and my inventory table where the tracking method is normal, so that eliminates all the grid records. And then I can link these two outputs together with a union statement. So that's going to really take two simultaneous queries and put them together with one output. Because I linked the item and inventory table, I need to say that this is coming from the inventory table. I've got a big item and inventory table here, but this is, I don't know if I can stop it, but this is going to export all of the gridded items and all of the non-gridded items kind of simultaneously. So you can put together multiple SQL queries with union statements, and the trick is just have the identical type columns, even if you have placeholders for things that don't exist. So I used an asterisk for the grid dimension 1, grid dimension 2, and grid dimension 3 when I was grabbing that data from my item and inventory table for the non-gridded items. Does that make sense? It's a pretty quick demo of that.
Thanks, John. Did anyone else have any questions? You want to put them in the chat or the Q&A at the bottom middle of your screen? Wes says thank you.
Thank you, Wes. It's a good question.